Hi everyone, welcome to practice number 8. We are doing chapter 10 right now. So now we're on histograms, and a histogram is basically the representation of the elements and its frequencies of each element. So if we were to use x as the elements and y for the frequency, we will have a histogram. So this code right now uses uh, specific that. So here's the figure, and that is the code. So for the first histogram, we are importing NumPy and matplotlib, and we have our array, and there we have the x and y for the elements and its frequency. And then we are just typing hist beans equal np.histogram, and it has the value of a, and we know that a has the array. And now we are printing the hist and beans, and we are showing it on the figure, and that's everything for the first one. Okay guys, so for the next one we have x that represents the scales of gray, and the y for the frequency of each scale of gray. So for the image we have that cat over there, and as you can see there has a lot of gray scales. So that graph has the frequency of each grayscale, so that will be the histogram. Here is the code. So then again we are importing numpy, matplot, and now we are importing cv2. Image equals cv2 and read, so it's gonna open the image that is on that location. It's gonna have a 0 to put it on gray, and then we have the subplot for space and h space and w space for the dimensions. The image is gonna have the name of it's gonna be gray. I mean the title original image, that is the title, and the title for the histogram is gonna be histogram, and that will be it. See you guys in the next one. Hi guys, so for the third program we are just modifying the last one a little bit, so this is another way of doing the same stuff. So that's the code over there. We are importing the same libraries. We have exactly the same code, almost. So it has a little differences from the last one, but it's basically the same one. And it's gonna do the same thing as the last one. Hi guys, so for this code right here, we are doing the same stuff, but for RGB colors. So it's gonna have the frequency of each times it has the red, the green, and the blue on the image. So it's a little bit more extensive than the last one, but it's basically doing the same stuff, but with RGB. So for example, in this image we have the cat with color. So in the red histogram, it's gonna have the frequency of the reds on the image. And the green histogram is gonna have the frequency of each time it has green on the image. And the same stuff goes with blue. It's gonna have the frequency of each blue scale on the image. So that will be it. This is the code right here. We have RGB on the image, RGB image 012. The subplots, of course, for each of the figures, and the range of each RGB 0 to 255. And well, that's it. Hi everyone, so for the program number 5 we have the same stuff. We are using RGB with the histogram, but in this case we are importing matplotlib. So this is gonna be the output, and that will be the frequency of reds, blue, and green of the image. So see you guys in the next one. Hi everyone, so for the program number 6 we are doing histogram equalization. So histogram equalization is an image processing technique. It is used to improve the contrast in an image. It's expressed spreads out the most frequent intensity values. This means that the intensity range of the image is stretched out. This operation increases the contrast of the lower contrast areas, which enhances the images. There are multiple ways to equalize histograms. One option is that we can use CV2 equalize hist. Um, the other method we can use is called contrast limited adaptive histogram equalization. Unlike global histogram equalization, it computes several histograms for the different regions of an image. This is also known as local histogram equalization. So here we have the original image, then we have the adjusted histogram, and the third one is the clock. Just as the example. So here's the code. So we're importing CV2 as the first method we mentioned, and the matplotlib. We are importing the image of the cat with color, and we have the RGB split image. So we are using the CV2 equalize histogram, and then we are merging in the output one, and then we have the clock, CV2 create clock, and the output with clock applying RGB. And then we have the titles. We have original image, adjusted histogram, and clock. And that'll be it. See you guys in the next code. Hi everyone, so for this activity, this is program number 7. We are doing contours for an image. It's gonna sharp the edges of the selected image. So we are using this technique. So here's the code. Really simple. We're importing CV2, matplotlib, image equal CV2 and read. So I'm gonna open the image with color, image CV2 CBT color, image CBT color RGB, and gray. Then we are equalizing original equals CV2 and read. So it's gonna open the next image. And then we have the titles for each of the images, original contours, and the corresponding for cycle in range of 2. So it's gonna do that with the corresponding titles. This is the output. See you guys in the next code. Hi everyone, so we are in the program number 8. So we are applying morphological transformations to an image. Morphological operations are mathematical in nature and they change the shape of an image. These operations can be demonstrated by visually. With binary images, we can apply morphological operations to eliminate a lot of unnecessary information, such as noise in an image. Our morphological operation accepts an image and kernel as inputs. We'll create a custom binary image as a binary image, since this is the most suitable way to visualize and demonstrate morphological operations. So here's the original image. The second image is erosion, so it's gonna take out unnecessary information from the image, from white and black. Then we have dilatation and finally gradient. Here's the code. So for this operation we are using an array and input as kernel. We have erosion, dilatation, and gradient for each cases. Then we have the corresponding titles and the corresponding cycle for. So that'll be it. See you guys in the next code. Hi everyone, so this is the last program of this chapter. We are doing the same stuff as the last one. So let's understand the meaning of these operations we demonstrated here. Erosion followed by dilatation is known as opening. So basically we are doing that on the first image, on open. Well, the second image, I mean. Top hat extracts small elements and details from image. Top hat is the difference between input image and the opening of the image. Black hat is the difference between closing of the image and the image itself. And finally, hit or miss is an operation that detects a given configuration or pattern in binary image. So that there are the 6 cases. Well, the first one is original and the 5 cases. Here's the code for the corresponding output. We are using the same array, and that'll be it. See you guys in the next one.